Donald Trump demanded NASA land humans on the moon in 2024 and increased funding for the agency, but the deadline kept shifting to the right. Now even 2027 is in question. Industry experts doubt Axiom's ability to create a spacesuit for lunar conditions. In parallel, Elon Musk said, "We will fly straight to Mars. The moon is a distraction." The billionaire's critics suggested that he was having trouble with the landing module and wanted to get out of the lunar project while saving face. And then the media also investigated that the new leadership of NASA plans to abandon the SLS rocket and the Orion spacecraft. That is, except for Musk, who gave up on the moon, the agency will simply have no other carrier capable of delivering people to Earth's satellite. From the outside, the Artemis III lunar program looks like poorly managed chaos. Does this mean that landing on the moon won't happen in the next few years? The photo below shows an astronaut on the moon during the Artemis III mission. The picture is not just an artist's fantasy. It shows the scope of ambition of the planners of the new mission. The spacesuits of the times of the first flights to Selene did not allow anything like this. It was unreal to bend legs at 90 degrees and stand in them. Astronauts moved barely bending their legs, and sometimes even jumped. Now, mankind knows much more about the moon and, in theory, should be capable of new achievements there, including the exploration of the moon's south pole, which is rich in ice and permafrost, and providing astronauts with fundamentally new technical means. Let's imagine that we have been invited to lead a long and complex project, the intricacies of which are sometimes not fully understood by the developers. After all, they were once called in to correct the faults of those who came before them. This is the situation with the project Artemis III, the return of astronauts to the moon in 2027 or later. The current solutions to the project seem like a dead end. But what went wrong, and how might events unfold? The Constellation project was launched in 2005 with the goal of returning to the moon no later than 2020. 15 years seemed to be a sufficient period at the time. The previous lunar project in 1961 to 1969 was half as long, and this on grandfather hardware and software. Then, 20 years ago, NASA expected to fly to the moon, land, and return completely independently, as under von Braun, giving contractors the general technical appearance of the product and controlling the way they build it. There are 4 key components in the lunar programs: Super Heavy Launch Vehicle, spacecraft, landing module, spacesuit. It would seem that success is inevitable. After all, the program planners initially reported that in order to save time and money as much as possible, they used the engines left over from the Space Shuttle program. After 4 years, it became clear. Overruns on the development are so great that without a sharp increase in the total costs of the program, it is unrealizable. It was cancelled, but NASA did not give up and rebranded the Super Heavy rocket for the moon Ares in SLS. The ship Orion was not renamed. There was a minimum of changes in the project, and the lunar landing module Altair was postponed until better times. Best times for a return to the moon developed during Trump's first term. In 2018, he finally sanctioned the Artemis program for this purpose. But by the early 2020s, it became clear that finishing all 4 components of the lunar program in-house was utopian for the agency. The finalization of SLS and Orion rockets was already in the second decade, and the final was not seen. NASA has not succeeded in developing a spacesuit at all. It was risky to start a module under such conditions. In 2019, this is the spacesuit NASA head Jim Bridenstine introduced to journalists as the future lunar spacesuit. Then, the agency decided to get rid of criticism for punctures in the development and make it a future target of private developers. The lunar landing module was entrusted to SpaceX. In fact, it turned out to be a Starship with landing legs. 2 private companies were hired to make spacesuits, Collins and Axiom. Axiom Space is showing off a new spacesuit for the moon in 2024. Alas, it does not yet have a life support system. Collins simply withdrew from development, saying that it is too complex a task. And Axiom, even at public shows, demonstrated the models being created without life support systems. In addition, at one of the latest shows, people saw a clone of a prototype NASA spacesuit from 2019 but with colored design inserts from Prada. By the way, there will almost certainly be no large inserts in the real lunar landing for technical reasons. As if spacesuits weren't enough, the situation has been simultaneously exacerbated by both Musk and his political opponents. Seth Abramson, for example, thinks the latter has lost his mind. By the way, he calls himself Elon Musk's biographer. although the existing biography was actually created by Walter Isaacson. Anyway, on January 7th, Abramson suggested that the Biden administration break all contracts with Elon and begin prosecution. Except that without contracts with Musk, not only Artemis but even the banal return of American astronauts from the ISS is difficult. In fact, we are talking about a proposal to deprive America of manned spaceflight. The owner of SpaceX isn't letting things get boring either. As I wrote above earlier this year, he stated, "We're going to fly straight to Mars. The moon is a distraction." The media, as usual, presented it as hype as possible. Say, the most important person in the American space program does not want to fly to the moon. Then there were witnesses to the conspiracy. SpaceX is not doing well with the lunar module, for which NASA paid the company $2.89 billion. Here he is trying to find an excuse not to follow the contracts. In fact, Musk wrote these words in response to a question from another space enthusiast. The latter asked if Starship going to Mars should be refueled with lunar oxygen. The question at first glance is reasonable. 69% of the fuel mass of such a ship is oxygen. Answering, the head of SpaceX meant that refueling on the moon in the conditions of reusable carriers does not make economic sense. It is easier to deliver oxygen from Earth than to build a mini-city on Selene for O2 extraction. Let it be a hype, but still, Artemis III by 2025 has accumulated quite serious problems. The Orion heat shield returned after the orbit of the moon was cracked. That is, another test flight of the ship is needed. But there is no money for it. The Artemis project has generated such an expensive rocket, SLS, that one of its launches with the ship costs $4.1 billion. The head of SpaceX summarized all this. The architecture of Artemis is extremely inefficient. This is a program to increase employment, not to achieve results. Something fundamentally new is needed. Let us return to the place of the invited project manager and ask ourselves a question. What would we suggest to ourselves? One often hears, why does Artemis even need a lunar module and ship separately? We are already seeing the 7th Starship test flight. Yes, there are flaws, but it is obvious that by 2027, it will be flying regularly. There are also unlikely to be problems with the life support system, as SpaceX has already made one for Dragon ships. Why not take astronauts to the moon, land them directly on Starship HLS, and then return to Earth on it? This approach to project management can be tentatively called new Broom. Often, a new manager wants to radically change everything, to sweep away unnecessary crutches left by his predecessors, and then make everything normal and fast. In practice, this approach is not applicable. First, for a launch from Earth on a ship without a very large statistics of accident-free flights, it is desirable to have an emergency rescue system. Technically, this is a set of small engines to separate the ship from the rocket if it malfunctions. And, of course, a parachute system for atmospheric braking. Starship doesn't and won't have all of that. Otherwise, the ship would have to be radically redesigned, which takes a lot of time. And the developer doesn't want to, noting that airliners don't have parachutes. And Elon Musk is going to make an airliner for space, a mass and cheap carrier, not a simple experimental airplane with a parachute. Then, there is a temptation to take another ready-made piece of space technology. The manned SpaceX Dragon. Launch astronauts into orbit on it, dock it with Starship, and then launch it to the moon for a human landing mission. This would solve the problem with the escape system. The Dragon has one. But for all the appeal of this option, it is quite difficult to implement. Existing versions of Starship simply don't have enough fuel to fly back to Earth from the moon after the astronauts lift off. Unlike a ship like Orion, Starship is very massive. Of course, it is possible to refuel Starship in near lunar orbit and then return it to our planet. But that would require many additional Starship tanker flights. To send one fuel tanker to the moon, it would have to be refueled in Earth's orbit. What if, during landing or takeoff, a Starship tanker damages the launch equipment at one site, say, Starbase in Texas? That would clearly block the next flights from there. The wait for refueling could get longer. And what if another tanker damages the launch spot at the second launch pad for the Starship being built in Florida as well? Will astronauts wait months in orbit, enjoying the magnificent views? Physicist Casey Handmer, who used to work with NASA, offered a different solution 4 years ago. Yes, for a full-fledged Starship with a 100-ton payload, a return from the moon is realistic only after complex refueling in low lunar orbit. But what if the ship's payload is reduced on the first flight? Handmer calculated that with 25 tons of payload, 12 refuelings in low Earth orbit would allow the ship to fly to the moon and return. Refueling in higher orbits is theoretically possible. It would give Starship the ability to deliver 200+ tons of payload to the moon and then return the crew and tons of lunar soil. But there just isn't enough room inside the ship for 200 tons of cargo. Unless you want to mount an Olympic swimming pool inside and launch whales into it, the physicist notes. If anyone doubts the scientists' calculations, it is not difficult to check them yourself. Delta V, the energy budget for reaching certain points of the solar system, simply put by how much the ship's speed should be changed, is well known. First, note that all calculations on this indicator for Starship are given after the launch into low Earth orbit. In any case, refueling will take place there. The tanks will be full, and the Delta V countdown should be started again. To get from low Earth orbit, 200 kilometers, to geotransition orbit, from about 200 kilometers at perigee to 36,000 kilometers at apogee, you need a delta of 2.44 kilometers per s. To go to the moon, from this orbit would require 0.68 kilometers per s of additional velocity. To reach a low lunar orbit, 100 kilometers above the moon, another 0.82 kilometers per s. Landing on the moon is already more difficult. There is no atmosphere here, against which we can extinguish the speed. So we will spend 1.72 kilometers per s delta V for braking on landing, and another 1.72 kilometers per s for takeoff a few days later. Another 0.82 kilometers per s is needed to send it to Earth. That is, the total delta V, after reaching low Earth orbit where refueling will take place, is about 8.2 kilometers per s in total. That is quite capable for Starship with those parameters of the engines, 380 seconds of impulse in vacuum, which are planned by SpaceX. 25 tons for 3 astronauts may look like a severe limitation. After all, not only do they and their in-ship and out-of-ship spacesuits have to be stuffed into that load somehow, but also the equipment for traveling on the moon. Without lunomobiles, traveling in the lunar shadow at -190 and below is no easy walk. It's worth remembering here that the mass of Apollo-era lunar modules is an unhelpful load. Namely, the total mass was only 12.5 tons. Sure, on the way to the moon, the astronauts used the air, water, and food of the command module, which didn't fit into those 15 tons, but their total mass didn't even reach a ton. So maybe the astronauts in 2027 will have to shrink, but they certainly won't have to sleep sitting up like their 1960s counterparts. I don't think we should sympathize with astronauts about the tightness just yet. Musk, who employs his own style of project management, has heavily revised the final look of his brainchild over the past 3 years. Starship Vi-3 should already have a payload of 200 tons, not 100 as Handmer had calculated. At the same time, the fuel mass is 2,300 tons. That is, full refueling in orbit will require about the same 12 tanker flights as before. What in Handmer's calculations looks problematic? He thinks it's rational to land Starship HLS directly on Earth with people inside. This is questionable for 2 reasons. First, then it needs heat shielding like a regular Starship, and landing legs like its extraterrestrial version. There is no Mechazilla on the moon yet. Secondly, landing with astronauts can be done only after several tests without humans. The spacecraft is new. Besides, if we first send one Starship to the moon with cargo but without the task of taking off again, it will have a surplus delta V of at least 2.54 kilometers per s. It is possible to place not only lunomobiles but also mini drilling machines, which are very useful for studying the south pole of the moon. Let's summarize. The most realistic scenario for rebuilding the lunar program under the new administration is Handmer's version, only slightly modified, in which people will get on board the Starship in Earth orbit with pre-launched Dragon. Such a launch will throw out of the flight program 2 launches of Orion on SLS, the first to test the updated heat shield and the second with people on board. In total, it saves $9 billion. There have been leaks in the US press that seem to say that Handmer's option has already been adopted. In December 2024, renowned journalist Eric Berger presented data from his sources in the industry. The new NASA leadership is planning to abandon Orion and SLS. Technically, this is only possible if the new head of NASA, Jared Isaacman, commander of the first private space crew in history, plans to rely solely on SpaceX technology to fly to the moon. Of course, Bill Nelson, head of NASA, tried to deny that leak, He gave an interview to the same Eric Berger and stated that Trump would not risk scrapping Orion and SLS, so as not to lose the race to the Chinese and definitely have time to see astronauts on the moon before the end of his term. But I will remind you that NASA astronauts did not just affectionately nickname Bill Ballast Nelson. The nickname has a basis. The politician is not very well versed in space issues. For example, he stated that one side of the moon is dark all the time. Of course, that's better than if he thought it was flat, but his overall level of understanding of the Artemis issues is still hard to call excessively high. The position of Nelson and other politicians whose careers have been associated with SLS and Orion is understandable. They don't like the prospect of curtailing job growth programs. They've spent a lot of effort to maintain them and have associated their name with their success. Except neither Trump nor Musk are involved, and a Handmer-esque shakeup of the lunar program could very well become a reality. That's not to say there's an easy ride ahead for astronauts on their way to the moon. The issue of spacesuits is not yet closed. If we do not radically accelerate, then by 2027 there may be no working iron. The Starship trials are another non-obvious story. On the one hand, they are progressing rapidly. On the other hand, it is a reusable system. You need more flights to be sure of its reliability than with a disposable one. Personally, I expect more than a dozen Starship launches this year and a few dozen in 2026. And next year there will mostly be not so many test flights as satellite-oriented. Perhaps this is the most reliable link of the American lunar program of the Axiom century. Therefore, the decision to bet on it and get off the stagecoach such expensive passengers such as Orion and SLS looks really logical.